All right, guys. We are given a question here to solve. Prove that the electric potential energy stored in the plate of a capacitor is U equals to half QV or half Q squared divided by C. We are asked to prove that electric potential energy stored. I want us to note that the energy stored in the capacitor is same as the work done by that capacitor, the work done on the capacitor. Okay, and that work done is equal to change in work done is equal to change in charge multiplied by our voltage. It's like saying work done equals to what? QV. Okay, from this expression, let's call this equation what? 1. This is our equation 1. Then I want you to recall that charge is equal to our CV, right? Equation 2 is this. From here, we can make our V as the subject of the formula. So V becomes what? The charge divided by what? By C. Equation 3 is this. Our V equals to charge over what? C. So what do you notice here? Let's put the value of V into equation 1. Let's substitute the value of what? Of our V as Q over C into equation 1. And that will give us what? Our change in work done equals to change in charge multiplied by the charge itself divided by what? C. Now, we are already saying that this is leading us to what we call integration, right? Integration. But I have to introduce the principle of integration to be able to find the work done, which is same as the potential energy stored. Okay, so what we do here is that we have to integrate both sides. We integrate both sides. We integrate both sides. By the time we integrate both sides, that means that integral of the change in work is equals to integral of the Q multiplied by Q over C. I can bring out 1 over C because this is like saying 1 over C times Q, right? So we have here change in W equals to 1 over C. The integral of what? Of Q dot what? The Q. The right to integrate charge is actually the Q, okay? So we can integrate. Don't forget the principle of integration. Now, if we have integral of s raised per n, to integrate this simply means the rule says we add 1 to the power of n, then divided by what? The resulting power, n plus 1. Right? So that means that by the time we integrate the change in work done, we're going to have work done, which is equal to 1 over C multiplied by Q1 plus 1 over 1 plus 1 plus C. Right? The rule of integration simply means that when you integrate a value, always add your constant C to it. Because I want to define work, I'm going to remove my constant. That means our work done is equal to 1 over C multiplied by Q squared divided by 2. This is same as work, which is same as our energy. Don't forget that the energy stored is same as the work done on the capacitor, which is our U equals Q squared, divided by what? 2C. Because Q squared times 1 is Q squared, 2 times C will give us what? 2C. So we have been able to derive the first expression. So this expression can also be represented as half Q squared over C, right? Half Q squared over C. But we can also use our capital Q, which is Q squared divided by C. Now, from here, we can also express this to be half times Q over C multiplied by Q, right? Because Q times Q is Q squared. But remember that we say that Q over C is equal to what? V. So this Q over C will represent our V. So our energy then becomes what? Half what? V times Q, which is same as what? Half QV. Okay, we have seen the second derivation of this formula.